Welcome back. So today we will discuss about the layers of data processing. That is, when you are working with the data, so you might have encountered with the different data layers. So especially if you are a data engineer, data scientist, or data analyst, you might have heard about these different terminologies or different words or different slangs that we call for data layers. It might be raw layer, landing, staging, harmonized, bronze, silver, gold, or archival layer. So these are the different layers when you are designing the data flow, basically as a data pipeline, and uh, and it is very important to understand this concept in detail so that when you're working in real-time projects, so this will come handy. So this understanding or this knowledge will come handy for you. So we will discuss in this video, we will discuss why exactly we need layers, different layers, and what is the importance of this. And also we will discuss each layers in detail, what is the purpose of having this kind of layers. And also at the end, we will see the different like one or two projects in detail. We'll take a use case and we'll try to apply these different layers to that use case. So before proceeding, if you are new to this channel, we would recommend you to please subscribe and also press bell button for instant notifications. So let's get started. So as per the agenda, we will discuss what is data layers, what are the what exactly the data layer mean, right? And why we need different data layers. So this is very important, right? So we need to understand why. So if you understand why we need different data layers, so then the understanding of other concept would be really easy. And what is the different data layers, and we can see that with the examples. And also we will see the importance and reasons why we are using per each and every layer here, right? What is the importance of each layer and what is the reason we are using that layer. And at the end, we will see two real-time scenarios. We will take use cases and try to apply these data layers and explain so that it will be quite relatable to understand. So now, what is data layer? So data layer, when you talk about it, represent different stages, right? So when you design a data pipeline, so when you design it, when you bring the data from the source to target, right? So data layer is something that it starts from the source and it end with the destination. That means it is the entire journey of the data from starting to the ending. So that means like uh, when you design like ingestion, right? You start the data ingestion with the connectors and you connect to the source systems, and after you get the data inside, what you exactly do with the data, how what is the journey of that data. So that is the and to to explain that journey, so we will use data layers. So each layer serves a specific purpose here, because so it is not like we are using layers just to segregate the data. So there is different use cases, specific use cases for each data layers. And also the data refinement, right? So each layers the data goes on refining for a particular use case and particular need, right? So that is where the name comes in, the different data layers names comes in, right? So that is what we call as a data layer. So before we understand why, so as you saw in the agenda, right? So we wanted to understand why we need a data layer. So to understand why we need a data layer, so it's quite important to understand the data life cycle in the enterprise project. So you take any projects, so in the like data engineering, data science, AI, ML, any kind of data projects. So this will be the data life cycle. That means, as you can see, so first we will start with data ingestion, right? In any project, so data project, it start with the data engineering. That means the data ingestion especially, right? So once the data is ingested, so that means the data comes from different databases, file systems, right? Data lakes, APIs or streaming sources and all. So once the data is ingested, so that needs to be organized further and collected in a particular format so that it can be easily used for the further transformations. And in the data cleaning process also, we kind of clean the data using by fixing the missing values, correcting errors, ensuring the data consistency is intact. And also we can store the data in a particular format in the databases and data warehouses for easy retrieval. And also we provide a certain kind of indexing so that the querying and the processing would be much faster. And then comes the data transformation, where you perform the data transformation into a more suitable format for the analysis and reporting as per the requirement. And here it might involve aggregations, joins, creating new features, or converting data into a different types, right? So that comes into picture with along with the data enrichment, where you kind of uh, like uh, like enrich the data with the business use case that you want. So existing data with the business other transformations, complex transformation, you can enrich the data. And further you do the data aggregations and analysis, so where the data aggregations takes place according to the certain KPIs, right? And which is used for the reporting. And finally, the visualization and the reporting layer will comes in, where you start designing the business intelligence reporting and the visualization dashboards and all. And once this all is complete, so finally once that is productionalized, so the entire process has to be monitored, maintained, right, on a daily basis, so that there is a to make sure that all the entire data life cycle or the pipeline data pipeline is working as expected. So this is, so now it is generally, you can imagine, right? So how complex, or what are the different activities that a data pipeline or a data life cycle has, right? So to make sure each and everything is whatever we are seeing here is to ensure these points are taken care on an everyday basis. So we need different layers to we need to segregate the data into different layers so that it can be easily manageable. Otherwise, we cannot put a different rules, and you cannot control the data if it is not properly segregated and organized into a different layers. So that's the whole purpose of having data layers here, right? So hope this was useful. Basically, to understand, this slide is basically to understand why we need a data layers. So because of this complexity, or because of this maintenance, and because of these kind of steps has to taken care on an everyday basis, so we need a data layers so that it can be easily organized and maintained. Right. So next, actually, let's jump to the main topic, that is to understand types of data layers. So what are the different types of data layers, right? So the data layers, actually, this is not an exhaustive list. First, let me clarify that. So people can call it in different other names, but these are the most commonly used data layers. So apart from that, there are other layers as well in the industry. They might name the different words, right? But these are the most commonly used, so that I have picked these data layers here. And to start with, the raw layer. The raw data layer is actually is an initial stage where the data processing starts, where you actually connect with the different sources, different databases, different file systems, right? And it might be API connection. You might connect to a different streaming source systems like IoT, Event Hub, Kafka, etc. Right? So, and once you do that, so you bring the data into your system. That means you're into your project. So that is the layer where we call the raw data. That means it is in the raw format. The data comes as is, right? So this layer is very critical in preserving the integrity and authentication of the raw data, because it is unaltered, right? So it is, so if you take any other layer, so that might have some data alteration, but the raw data is it always in its raw format. So the example for the raw layer is so like let's take a there is a customer, right? So customer who is performing some kind of a transaction, and that transaction will be logged as a logs into the e-commerce database, so that with the details like what is the customer ID, what is the product ID, and what product he has purchased, and all those things, right? So that will be logged into the customer table, right? The transaction table. So that is a best example of raw data. That means that is unaltered data. So next is a staging layer. So staging layer is basically it is a basic cleaning and formatting. So what that means is it is an intermediate stage. That means after raw layer, it usually comes where like in this layer data undergoes preliminary processing. That means it is not like completely processing or complete cleaning. It is preliminary formatting, for example, so you have a raw transaction logs, right? Coming from the different source systems. You perform a basic cleanup, maybe like ensuring that the timestamps are in a particular format, and you might be getting like integer or like double float, whatever the data types you are getting. So is the data looking good? So those kind of certain very minimal standard level of formatting that you will be looking for in this layer. And this is a primary purpose of staging layer actually. And it acts as a buffer between raw layer and the next upcoming layers, right? And this is about the staging layer. And let's discuss about a bronze layer. So the next layer is bronze layer, where this is also an intermediate layer basically, and it follows staging layer. This is a layer where more advanced kind of a cleaning will happen. So, and for example, in the bronze layer, what happens is additional cleaning is performed such that the delta with the outliers basically in the transaction amounts and standardizing some product names, right? For example, so those kind of operations will be taken care in the bronze layer. And next is a silver layer, where little more advanced kind of a data processing pipelines will be designed for which is after the bronze layer. So after bronze layer, you have a silver layer. At this stage, the data undergoes further refinement. That means for the which is suitable for the transformation and enrichment to prepare it for the complex analytics and modeling. So here, in the silver layer, the main purpose of silver layer is to create high quality data set, right? So see, the next layer will be gold layer. So gold layer means where exactly the business level transformations will happen, and where the business people will start using this report. So to perform this gold layer, what is the prerequisite? So with the respect to that prerequisite, the silver layer is prepared. Or you have a gold layer. So gold layer is actually at this stage the data is refined into its highest quality. That means it might be like structuring and organizing for optimal performance for reporting and business intelligence and other decisions. Basically, like this is where your business intelligence dashboards, right? Like BI dashboards, like Power BI, Tableau, whatever dashboards, right? So those dashboards will be connecting to these layers, and maybe some reportings in the form of PDF, Excel, whatever goes to the business, or it may be available to the business. So this is where the data lies, the final layer of the data, where it is completely fine-tuned with no data quality issues, or and it is having all the data processed, which is the business according to the business reporting requirements. And for example, the data in the gold layer, right, the data is optimized for efficient querying analysis. So that is the whole purpose. So usually this layer will be stored in the data warehouse, because once the data is stored in data warehouse, so you can so it basically it is more effective for querying and analysis, and it might involve some kind of denormalization as well. So creating a master data set so that it can perform in a good performant manner. And next is a harmonized layer. So harmonized layer is again, it is an optional layer, but a few projects or few enterprise level projects will use it. So this is very advanced kind of a data layer which comes after gold layer. So this is not mandatory, as I said, right? So most of the projects will use still gold layer, and few projects use harmonized layer. So harmonized layer is on top of the gold layer. That means it is more refined or more advanced version of the gold layer, where it ensures the consistency, standardization, and unified representation across the organization. So basically, the harmonized layer, data layer, is used in a case where this data is extracted for multiple by the multiple projects for multiple use cases. So that is where the some kind of standardizations and some kind of unified representations are taken care. So here, so that the primary goal is to cohesive and comprehensive view of the data that is ready for cross-functional analysis. So this is not just for the sake of business users or someone, right? So this is used for higher kind of analysis and data aggregation. So the final layer is archival layer. So this is like again optional layer. So few projects use this. So where the simple archival is you have is like you whenever there is a need of archiving the data, the historical data which is we are not using for the long term, that is data which is older than 6 months, 10 months, or maybe 3 to 4 years, you start archiving. That means you start purging it, or you will move the data into the cold storage so that you can save the cost of that storage, and but still you retain the data into a archival layer, and whenever you need that data for some kind of auditing or some kind of data triaging, so you can have that data in your back of the pocket. And that's what we call as a archival layer. So archival means, for example, you can archive the financial transaction record for the long term compliance and auditing purpose. So that's the best example of archival layer. So these are the just a brief of it, but we will go in detail of each of these layers in the next coming slides. So first let's start with the data layer. I mean the first layer, that is a raw data layer. So here, as you can see, it is a initial stage, right? So initial stage in data processing pipeline where data is ingested in its original unprocessed form directly from the various sources. Right, and this plays a very crucial role in preserving the integrity and authentication of the data, authenticity of the data, serving as a starting point of the subsequent coming processes. So that means here you get the data from different sources and you just dump the data into a particular location. So usually this location will be your data lake, blob storage, Amazon S3. So where it is cheaper kind of a storage solution, because you need large volume of data here, right? So that is why you bring and dump the data here. And usually this data is in the original and unaltered format, because you're just dumping the data as is. And so since you are just not doing any column level filter or row level filter here, so this data is having a high volume and also has high variety. So basically it can include structured, unstructured, and semi-structured data as well, right? And so here all the timestamps and metadata of the raw data is maintained so that it can be used for further data triaging or further to maintain a data lineage. So right, and it also supports like it brings the data. This concept, right? It actually applies for both real-time processing and also the batch processing, right? Both kind of data ingestions and the source of truth and historical data. So that means so this will be a source of truth because this is unaltered data. So there is no transformation or there is no tampering of the data happened here. So that is why it any given case for any purpose you want the data to be revisited. So this will be your source of truth for anything, and also it maintains the historical data. That means it can hold a large volume of the historical data, maybe 2 years, 3 years. So that is one of the reason you can use the raw layer. And further data exploration and reprocessing, and also you can use this. So data exploration in the sense like when you are performing initial data exploration, right? That means you are still performing the data analysis and you want to understand the data much better from all the different possible dimensions. So from the data scientist perspective, from the analysis perspective, analyst perspective, right? So to find out the different patterns, different anomalies, and different potential insights, right? So that will be used for, I mean, the raw layer will be used for that. And also it is highly fault tolerant because it acts as a fault tolerant layer, ensuring that even if the downstream process fails, that means upcoming layer fails, the raw data remains intact for the recovery. So suppose if you have like further you have different layers, right? Even if the further layer fails, so you can reprocess the data using the raw layer. So that means you don't lose the data, and also you can retrack the data using the data lineage, because data lineage will start from the raw layer. So this is about the raw layer, and the best example of the raw layer, as I was mentioning, so whenever a customer perform any transactions, right, so the data will directly log into the customer table, or whenever a particular event happen in say take a IoT device, right? Whenever a temperature changes in a machine, so that temperature or temperature data will directly come using IoT hub, event hub directly to the raw layer of the system. So that is the best example of the raw data. So let us move to the next layer. So we'll discuss about staging data layer, right? So staging data layer is a intermediate layer again. So and in a data processing pipeline after raw layer. So first is a raw layer and next comes a staging layer. In this layer, data undergoes preliminary processing, cleaning and formatting to ensure that the data consistent and usable state before being passed to the next advanced layer. So staging layer again, it is not a mandatory layer. So we can use other layers like a silver. If you are using a medallion architecture like bronze, silver, and gold, staging layer is actually not mandatory again. So this acts as a buffer between the incoming that means a raw layer and next subsequent layers. So the best example why we can use staging layers is consider the raw transaction logs undergoing basic cleaning and formatting. Like say for example, there is a timestamp column which is not coming in a proper format, or there is an integer column or a double or float column rows are not coming in a proper format. So that kind of formatting you can do in the staging layer, right? So this is just a you can call it as a staging layer or you can call it as even the landing layer. So what are a few of the characteristics we can call, right? So there's a data filtering we can do. So we can filter irrelevant or unnecessary data columns, right? That is not required for the data processing for the next layers. And also you can format the data, like standardize the data. Maybe you are using some kind of currencies, you are using some kind of like exchange rates, right? So that you can standardize with respect to different countries, right? And also you might be uh, handling missing value, right? Say for example, you have a missing values in the data which is considered as a noise in your data. So that kind of data you can replace with some default values, right? So that it brings some kind of meaningful for it helps in the analysis. And also like if you are performing some kind of data quality checks, you can still do that, like say for example addressing issues like a duplicate rows or data outliers are coming. So those kind of data quality checks also you can perform here, right? And mainly when you talk about consistency and standardization, right? So data making it more subsequent for the further layers, right? And standardizing into that level. And data relevance is nothing but as we were telling, right? So keep the data which is only needed. So by filtering applying the row level filter or column level filtering. And data exploring and profiling, it means like say for example you are a data scientist or analyst who are exploring the data and you want to understand its characters before actually doing more deep dive analysis. So for deep dive analysis, you can pretty much use the raw layer, but some kind of high level analysis you want to do, so you can use the staging layer. So because it is much better than the raw layer to understand the data in some use cases, right? And also it detects and addresses basic errors and anomalies, right? So preventing them to propagate to the down into the downstream layers, that is next layers. And also it prepares the data for the advanced processing. So this is about the staging layer. So next, let's go to the next layer. So further, we will jump to the next layer, that is bronze layer. So in the bronze layer, it is next to the like staging layer, right? So after staging or landing layer, you come up into the bronze layer. But if you're talking about the medallion architecture, right? So the bronze layer is the first layer because in medallion architecture that we will discuss soon in this video, it is just the bronze, silver, and gold. So that's so in this layer, what happens is this layer is where more advanced data cleaning happens compared to the staging layer, where the refining and the structuring takes place compared to the previous structure. So here, data quality is a more important more important parameter, right, to address any kind of complex issues that we might encounter for the reporting layer. And also we prepare the data for further subsequent layer again. So as you can see, there are like a different characteristics we can see, right? So this is the advanced data cleaning. So when you talk about bronze layer, so you kind of apply sophisticated data quality rules to kind of handle any data errors or outliers that you identify and resolve that inconsistencies. And also you maintain that you build a error module or data quality module to log those errors into a separate database or separate table so that that can be addressed accordingly, right? And also, so here is where the normalization and standardization can takes place, where ensuring the consistency in units, like different units, right? Units of measure, formats, and naming conventions in the data happens, right? And the data will be completely clean. And also we can handle complex missing data, like because if you're performing any kind of machine learning or any kind of analysis, so you need high quality data without any missing values. So filling that missing value is a key aspect here by imputing techniques. That means by adding some additional data or filling the gaps or filling the data where it's a null, where there is a null or blank value. So you put that or you replace that data with some default values, right? And also there's a schema alignment is done. That means so each each tables, right, or each data set can have different schema. That means first customer table is having different its own attributes, right, and sales table it's having its own attributes, right. So that attributes will be clearly defined because we are talking about unstructured semi-structured data here, but when it comes to this layer, so the data will be properly aligned with the schema, which it will be which what are the different columns we are using here, that will be clearly defined in this layer, right? And also the data will be prepared for the feature engineering, right? So what is feature engineering? So it's one of the concept in when you're performing data science. So feature engineering is very important, where it is advanced feature engineering by ensuring that the data is refined and standardized state, right? And also you perform if you are into data science field, you might have heard about exploratory data analysis, that is EDA. So for EDA, you need a cleaner data set so that you can get maximum out of it, and also more refined data set is needed for analysts and data scientists. So that is taken care in the bronze layer. And also here the data enrichment for a context. So this is very important. That means so you might be using a particular data for a different use cases. So a particular data can be used for sales reporting. A same particular data can be used for customer behavior analysis, and the same data can be used for say for example to understand the to predict the like sales for the next quarter, right? So that is called we call it as a context. So for each context there is a different data enrichment we need to apply, so that will happen in the bronze layer. So further we'll move to the silver layer, where again it is also advanced layer after which comes after the bronze layer. So this in this layer, what happens is undergoes further refinement, transformation, and enrichment to prepare for complex analytics. So that is the difference, right? So here we are preparing data for complex analytics and modeling. The primary focus of silver layer is to create high quality data set that is well structured and optimized. So this is optimized, right? Optimized for advanced analytics here. So in the silver layer, so basically the data which is stored in the silver layer should be highly optimized to query or in terms of any performance, right? So that is where we call it as a silver layer. And if you like to further understand, so if you want to take an example of silver layer, right? So it might be involving calculation for new features, right? So if you want to, in data science, if you want to bring up new features like average transaction value or categorizing user based on on their purchases behavior, right? So those kind of things will be considered for silver. So like if we see the key characteristics of silver layer, so advanced data transformations, that means when you want to perform some sophisticated data transformation and feature engineering to derive meaningful insights from the data, so that comes in this layer. And aggregation and summarization, so this is important, right? So when before actually the reporting happens, before the final layer of reporting happens, that is gold layer happens. So you need to perform aggregation and summarization based on certain KPIs. So you have your own KPIs. So you might be your analysis dependent on country level or some product level. So those kind of aggregations you have to perform and summarization you have to perform here. And also when it comes to statistical analysis, so like statistics always depend on the patterns, some trends, some correlations within the data. So those kind of analysis it will be useful. And advanced, it also prepares the data for advanced analytics. And again, the pattern recognitions, right? So since it helps the statistical analysis, so it will also help pattern recognition to understand the behavior of the data and identify some pattern in the data, right? Like maybe pattern in the sense like pattern anomalies or trends in the data sets. And also it supports and provides the data science workflow. If you are a data scientist, so you need to use a silver layer for that purpose, where you get the refined and feature rich data set for the data science purpose. And to build, it will help you to build and train the machine learning models. And finally the optimization, right? So the structures the data to be efficient for querying for business intelligence purposes. So that is where it prepares the data for the gold layer, right? For optimize for BI layer. Next we will move for the gold layer. So this is a final stage of data processing we can call, where the data is completely transformed into its highest quality available, and it is completely structured and organized for the optimal performance for reporting. That means the final, you might be having some reporting layer like Power BI, Tableau, or any kind of reporting dashboards, or you have like any kind of Excel, like any kind of reports getting CSVs getting generated, right? So that which is hitting, that will hit to this gold layer, where the data is completely transformed. That means whatever the business has defined the requirement in terms of reporting based on certain KPIs, so everything will be applied here. And so it is just a final consumption. The business has to just click the button, or business has to just use the dashboards, the final dashboards, so that they can get the data out of the gold layer, right? And if you see the high level examples, right? So the main example of gold layer is, so it is any report or any query or any analytics, right? So which involves denormalized, completely denormalized data, and creating a master data sets that is well organized. So that is the best example of gold data, right? And coming to the characteristics of gold data. So it is, as we say, it is optimized data set. So it is a well structured and completely optimized for efficient querying and analysis. Usually what happens is gold layer is will be stored in a data warehouse, because data warehouse is much faster in terms of reporting, and it is always good for reads, multiple reads, right? And data quality is the most assured here, and it's high data quality and accuracy and completeness of the data will be available here. And also here is where the business level logics are applied in this layer. And so performance is fine-tuned to the maximum layer level, because here is where the users are hitting, like there might be millions of users coming and hitting this layer, because that is where your reporting layer is dependent on. And also you might be having different downstream systems, because the gold layer is the last layer, right? So there might be different downstream systems also dependent on this, so it might hit the performance. So it is very important to keep the performance intact. And integration with the external data, because since the gold layer is almost the last layer, right? So if you are not using the unharmonized layer or harmonized layer, so which is the next layer, so then it will be last layer. So the integration to the external data uh, is done on top of the gold layer. So some kind of security aspects need to be maintained, because you are exposing this data to the external world or external users. So some kind of data security layer has to be maintained in this layer, so that all the users will not get access for the entire data set. So the user should access data only, maybe based on their roles or based on what they are intended to look for, right? And also it's having enhanced business intelligence capability, right? So because so this is at last layer, right? So it has to support like a dashboarding level of capability and providing actionable insight to the stakeholders. And also this gold layer also can be more interactive, and also it can be real time or even real near time. It doesn't mean that gold layer is always batch, right? So the end to end from the raw to gold, it can be maintained or it can be designed in such a way that it is in a streaming, and it the real time reporting or real time dashboarding can be performed. So this is about gold layer. So now quickly jump to the unharmonized, I mean the harmonized layer basically. So harmonized layer is it is advanced again stage on top of the gold layer. So this is again optional layer. So most of the projects doesn't use this unharmonized, I mean harmonized layer, because the the gold layer serves the purpose for most of the projects. But if you have a use case where so this is a peculiar layer where you have a different kind of use case. It is not just about getting the data, fetching it, and storing it for the data science and data analyst and just reporting it, right? So this harmonized layer is used in a scenario where you have a data consumed from the different projects, right? Different sub projects. Basically, if you are designing a data mesh kind of concept where your data is served to different projects, so in that case, you will design the harmonized layer. That means here you centralize the data from the different systems, and basically you perform master data management where you standardize the data into a particular format. Suppose you have a particular column, right? Like column like customer ID, right? So you call customer ID in one table, and in another table you call as cust ID, right? So those kind of standardizations, that level of standardizations also can be done so that at the enterprise level, so we talk about a same language, and those kind all the tables will be ingested into this layer, and the each columns and even the data and data formatting will be standardized into a organization standards, so that any other project which is talking to this particular layer I mean knows what it is referring to, because it is completely standardized. So this is one of the peculiar use case, and many of the project use this harmonized layer, but generally if you are talking about data science or kind of a reporting projects, so this is not for that. So this is like a advanced kind of a data mesh or data fabric where you're using it. So in that case, the data harmonization layer will come into picture. The primary goal is to provide cohesive and comprehensive view of the data that is ready for cross-functional analysis. That means different functional systems will come and interact here, and different projects can utilize this data for reporting and decision making. So if we talk about the key elements or key characteristics of this is definitely the data integration, because so here as we talk about data mesh or data fabric where the data will be coming from the disparate sources. That means so each source system will be having its own what we call own behavior on defining its own column names in different standards, right? So here in different departments, systems, external partners, everything is there. So you need to bring that data or data columns or table names into a canonical kind of format. That means a standard format. So that is where the data integration challenge comes in, and consistency of the data representation, because the data has to be represented in a proper naming convention, units and formats. And also it is used for cross-functional alignment. That means so you have to align data across different business functions, allowing for seamless collaboration and analysis. That means so you talk the same language. So that's important here, right? And unified data model, because so that's the purpose of this, right? You are centralizing the data and distributing the data. So when you do that, so you have to design that model in such a way that it is unified data model that represent the organization data in coherent and standardized way. And you have a data and governance also, because so when it comes to the here we are talking about data mesh or data fabric, where you're distributing the data and it is integrated with multiple systems, so the data security and governance will come into picture, and you have to maintain the data quality as well, right? And it also have the 360-degree view. That means creates a comprehensive views. That means, for say for example, you have a customer, you have product, you have like sales tables, and consolidating the data from various source systems. So you need to bring that 360-degree view for different. When you talk about master data management, so this is MDM. So if you are having any project which is talking about master data management, that is MDM project, or you want to build a MDM project to standardize the data, so then so harmonization of the data layer is very important, and this layer is what this layer is doing, right? So it actually doing, if you see that standardization, consistency, unifying representation, and also it is actually doing cross-functional alignment. So these are all the concept of MDM, if you talk about, right? So the MDM want to do the same thing. It want to build a unified data model which will be used from the different projects. So when you're talking about creating a master data management project, so definitely this is the harmonized layer is where you need to explore more and build into your system. So next comes the archival layer. So this is very simple, where you archive that unnecessary data. That means unnecessary in the sense you have continuously your project is running for 5 years, 10 years, right? And you need not store the entire data into your processing system, because you cannot pay for that storage, because today the storage might be 500 GB, but after 5 years it can become like 3 TB or 5 TB, and you cannot afford to pay that much of storage. And also if you're using data lake or kind of which is in the hot tier, right? So hot tier, any storage in the hot tier systems or structured database systems, so that will be a overhead basically, in terms of cost, right? So you cannot afford to store that much of data. So you move the data into a secondary storage. That means secondary storage, when I say that, it can be any storage where it is a cold storage, right? When you say cold storage, it can be low cost storage systems, right? If you talk about in cloud also, we have a cold storage, or you have a ultra cold storage, where you can store the layer data into the with a very less kind of a cost, and you can retrieve that data whenever it is needed. So there is a retrieval cost for that also, right? And so it is basically to store the cost, and also to maintain the compliance and legal requirements for any historical data, and also to maintain the data for any triage issues if it comes in future, data triage issues, and to kind of identify data issues. And this is basically for the long-term retention. And retaining the data means that you want to keep the data for some purpose. That means some purpose in the sense it might be any legal compliance, because any each country has their own regulation, each project, each organization has their own compliance and regulations to store the data or purge the data for a particular number of years. And also if you're having any financial audits happening, right, so the auditors will definitely ask you the data for validating, right? And the logs and event data is the best example, right, where you get huge amount of data and you want to archive that. And data is stored in the immutable format. That is, data is not changed here, right? So that is where the advantage is. So since it is in the immutable format, so it can be retrieved for any further analysis. And the main purpose is again the compliance and regulatory requirement, because each as I said, each country, organization, projects have their own compliances, right? Especially the if you are working in the financial and banking projects, this is very important, where the compliance and auditors basically will check whether your data is maintained properly into the archival storages. So this is about the archival layer, right? And the best example is storing the financial data or archiving the financial data into secondary storages, so that if any auditor comes and asks for any kind of auditing purpose, so you can retrieve that data from the archival storage and hand it over to for the auditors to check that. So this is about archival layer. So now that you have seen different kind of data layers, you might have been confused or you might be wondering. So few layers might be coinciding. Like say for example, you're talking about silver layer, you're talking about staging layer. So both might be doing similar activities, right? So or if you talk about like bronze layer and silver layer, so sometimes they might be doing a very similar operation of filtering or performing some data quality checks, right? But so the important thing here is we are not using all these layers in all the projects. So if you talk about enterprise projects, so we might use all the layers in a particular project, but it is very rare, I would say. In the enterprise level projects, you either use case one, which is very simple. As you can see here, you have a raw layer. So you ingest the data into this layer, dump the data into this layer, and perform some kind of cleaning or cleansing activities here, and then you make the data available for the transformation layer, that is transformed layer. So here transformed layer can be again, it might be a silver layer, gold layer. Mainly it will be a gold layer because it is the last layer in this transformation, right? So this is a simple use case. Most of the projects use this in reality because that is what it is needed in most of the cases. And in some cases, they will prefer using medallion architecture where they talk about bringing the data into a raw layer that which they call it as a bronze layer, and then they perform some filter cleaning activities in the silver layer. And finally, the business level aggregations and reporting happen at a gold layer. So this is what we call it as a medallion architecture because it is bronze, silver, and gold. So this also few projects use. As you see, like comparing to the use case one and use case two, it is just the naming convention. So what you like you can relate the bronze to the raw layer and silver to the staging layer and transform to the gold layer. So it's just a name that they are choosing here, right? And finally, when you talk about use case three, that is hybrid, where the people can use all the combinations of a data layer, and since if they are having a very complex projects, in that case, they might use this kind of scenario where they are using raw layer, staging, bronze, silver, gold, harmonized, and even they might be using archival. So, but the common factor here is to understand is, so in all these three slides, you see data quality, right? So data quality is always getting better when you move forward, right? You talk about raw to staging, staging to transform, or when you talk about bronze to silver, silver to gold, and you may talk about from here to raw to harmonized. So in all these three, the common point is data quality is always getting refined, right? So now let's jump to the real-time projects, right? So we will take a project, two projects here. So first project we will discuss here, which is a real-time banking analytics platform. So let's take this example, and this is the overview of the project, right? So to get to develop on a development of a cutting edge real-time banking analytics platform. This is a requirement basically, and strategically designing to revolutionize decision making within the banking sector. This holistic system incorporates various data layers. So this is the data layers. The requirement is to meticulously process, analyze, and the stored data in different layers. So this is the requirement, right? And this is a project. This is a banking analytics project we are talking about, right? So now let us discuss each of the layer and how this can be used for the banking use case and for to perform the analytics, banking analytics, real-time banking analytics we are talking here. So let's take a raw layer. So raw layer is a definitely it is a initiating the process. The raw layer captures unprocessed data from the diverse banking systems because banking systems can have a different data coming from different global locations, and it might have different systems, right? It might be having different ERP systems, it might be having customer databases and all. So it get the raw layer, the data from the different systems and preserve the data into original format, right? Into the in the raw layer basically, right? So this is the raw layer. And now next coming to the staging layer, so where it can position as a gateway to refinement, right? And the staging layer processes the raw data and apply cleansing and basic data quality checks to ensure standardization and reliability of the data set. And next comes the bronze layer where you perform some kind of advanced data refinement. The bronze layer addresses complex data quality issues, right? When you talk about this, and enriching the data for advanced analytics and for preparing for the more complex level of data modeling. And the next is silver data layer, where it is positioned for the advanced analytics. Silver layer basically employs machine learning models to gain insight into customer behavior, detects fraud analytics, detect fraud basically in real time, and optimize risk management strategically and dynamically. And finally, the gold layer, so representing the like high level of refinement, where it produces a structured data set for the reporting, and it supports a real-time reporting as well, and interactive dashboard and strategic decision making, where the enterprise, the banking executives can look into their reports here, right? And the harmonized layer, when you talk about, so this can have representation of some account level, transaction level, and customer details. It can create a unified data set with the standard formats, so that other banking project can utilize this data. And finally, the data archival can be performed to kind of comply with the regulatory requirement. It serves as a valuable resource for extensive financial analytics, and also offers some kind of insights in long term, basically trends, and supporting auditors for audit trails. So now let's go to the second project, that is a real-time project where we talk about comprehensive retail analytics, where we want to design and develop an innovative comprehensive retail analytics designed for transform decision making with the retail industry. So this again include all these layers, right? We want to build this comprehensive retail analytics platform. So when we talk about raw layer in terms of retail, uh, what happens is maybe it commences the data journey with the raw layer capturing the unprocessed data from diverse retail sources, right? So you, as a retail system, you might be having customer, you might be having some kind of sales, you might be having some agents, right? You might be having some wholesale systems connecting to the retail systems. So all those systems has to be the data from the systems has to be ingested. So that is done in the raw layer. The staging layer, where it can be performed some kind of analysis, right? Where you segregate the data into different customer level, or different data quality issues can be sorted out here. And the bronze silver layer, basically again some kind of a data enrichment happens for the advanced analytics, and especially in the silver layer, you can use it for some customer behavior and predict some trends basically, so that which will help you kind of have a predictive analysis on your retail customers, right? In real time basically. And in the gold layer is where you produce some structured data with optimized business intelligence, which will be which a retail dashboard or retail analytical dashboard can hold, and where the strategic decisions can be made. Like business executives will connect their dashboards or their reports to this gold layer, and they utilize this data for some strategic decision making at a higher executive level. So, and finally, the harmonized layer is again an optional layer where it can be used to represent some products, customer details, and transaction details that can be used across a different retail projects or different retail analytical platforms by standardizing the data into a organization standards or a enterprise standards. So, like some of the terms might sound similar here, but as I said, right, so all these layers, what we're talking is not mandatory. So few projects just use this, right? So as you can see, a few projects can just use bronze, silver, gold, right? And few projects might just use raw, staging, and harmonized, and few projects just might use raw, staging, and harmonized, right? There are multiple permutation and combination that people can use, and few people can call raw as a landing layer, right? So as I say, these are not dictionary defined, or these are not uh, architecturally defined words, but these are used for the convenience of each project and each enterprise. So it depends on how the data architects design this, or data engineers design this different layers, and what they call it depends actually. but these are the most commonly used slangs or the words that when we talk about data layer. So we want to explain this in detail. So hope this was useful and thanks for watching.